Hey guys, it's LJ with HEARTSTART and today we're talking about calculating the dose of a medication infusion when we're given the rate. So calculating the dose of a medication infusion when given the rate is a necessary step in confirming that the correct dose is being administered or if the dose being administered is unknown. The formula given is a basic formula that can expand to accommodate any medication infusion by adding or subtracting the variables. We can calculate the dose of an infusion given the rate of administration, and that's in milliliters per hour, or we can calculate the dose of a weight-based infusion given the rate of administration in milliliters per hour. So this is what our formula looks like when we set it up. It's our rate in milliliters per hour multiplied by our supplied amount, and then we'll divide that by our weight in kilograms multiplied by our time coefficient, which is always 60, and multiplied by our volume. We'll divide the top by the bottom, and when we calculate that, it will give us our dose being administered to the patient. When we're using our formula, there's a couple of pieces of necessary information that we must know. The first thing that we need to know is what the rate of the medication infusion is. That's measured in milliliters per hour. The next thing that we need to know is what the supplied amount of the medication is, and how is it supplied? Is it supplied in grams, milligrams, micrograms, or units? The next thing we need to know is what unit of measurement the dose was ordered in. We have to ensure that the dose and the supplied amount are measured in the same units of measurement, whether that's grams, milligrams, micrograms, or units. And if one is not in the same unit of measurement, we need to convert it using the rule of 1,000. The next thing we need to know is, was this a weight-based order? If it is a weight-based order, then that's going to be measured in kilograms. And then we need to know what the volume of the medication solution was, and that's going to be measured in milliliters. So let's look at a couple of practice problems. So for our first practice problem, we arrive at work and we get a report on a patient who has a Levophed infusion running. We walk into the room and we see that our patient is hypertensive. We look at our pump and we see that our Levophed is running at 75 milliliters per hour. Our Levophed was supplied as 4 milligrams and 250 milliliters. Our dose that was ordered is 10 micrograms per minute. Is this the appropriate rate for the order? Well, it seems like that Levophed might be running a little bit fast, but let's go ahead and check it. So we'll set up our formula, and you can see that we have 75 milliliters for our rate. We'll multiply that by our supplied amount, which was 4,000 micrograms, because originally we were in milligrams, so 4 milligrams. We used the rule of 1,000. We added 3 zeros behind that, and so we've converted it to micrograms. So we'll run our top, and then we'll divide it by our bottom, so we have 60 for our time coefficient, and then for our volume, we have 250, so 60 times 250. And when we run the top, 75 times 4,000 is 300,000. We'll run the bottom, 60 times 250 is 15,000, and we'll divide 300,000 by 15,000. And you see that our Levophed is running at 20 micrograms per minute. Seems like our infusion is going a little bit fast and doubled what our order is. So this time, we've been running an epinephrine infusion to resuscitate a pediatric patient, and we've been titrating to effect. So once we've reached our effect, we see that we're running at a rate of 52.5 milliliters per hour. So now the question is, what's the dose that's being administered to our patient? So our epinephrine was supplied as 8 milligrams and 250 milliliters, and our range for the order is 0.1 to 3 micrograms per kilogram per minute. Our documented patient weight is 14 kilograms. So what's the dose being given? All right, well, let's figure it out. So we'll set our formula up, and you can see that for our rate, we're at 52.5 milliliters per hour. We'll multiply that by our supplied amount, which is 8,000 micrograms. Because our dose was ordered in micrograms, we converted our supplied amount from 8 milligrams to micrograms by adding 3 zeros behind it. So we'll multiply 52.5 times 8,000 for our top. We'll divide that by our bottom. So our weight is 14 kilograms. We'll multiply that by 60. which is our time coefficient, and then we'll multiply that by 250 milliliters, which is our volume. You'll see that when we run the top, we get 420,000, and when we run the bottom, we get 210,000, and we'll divide 420,000 by 210,000, and we get 2 mics per kg per minute for our epinephrine infusion. Hey guys, thanks for tuning in today. We hope you learned something. Please see the show notes and visit HEARTSTARTNOLA.com for HEARTSTART NOLA reference cards, guidebooks, and other great stuff to help you with your pre-hospital, emergency, or critical care needs. This is LJ with HEARTSTART NOLA saying, see you next time.